What the heck is up, everyone? It's Jacob here, and in this video I'm going to be talking about Ohm's Law for DC circuits. So I'm going to try and make this video just kind of quick and concise, just to keep it very simple, but I want to emphasize here that this is for DC circuits. You cannot apply Ohm's Law to AC circuits at all. Okay, and that's one common misconception that a lot of people have, that you can apply Ohm's Law to AC circuits. I'm not really going to get into AC circuits in this video, but I just want to say that you cannot use Ohm's Law for AC circuits. AC circuits is a whole other animal. I'll make videos on AC circuits later, but I don't really want to explain too much as to why Ohm's Law cannot apply to AC circuits, but trust me, it can. If you want to argue that in the comments, go ahead and try that below, but you won't win. There is one very specific circumstance which you can apply Ohm's Law to AC circuits, but it's very specific and it's almost unusable. So I don't want to get into that, but basically Ohm's Law only applies to DC circuits. So that's the first thing you guys should know. Ohm's Law is for DC circuits, not AC. Okay, so now let's get into it. So Ohm's Law is, you have V equals IR. V is going to be your voltage. I is current or intensity. That's where the I comes from. It means the intensity. And then R is resistance. So these units are volts is for the V. I, these are going to be the amps. And this is ohms. Or you'll have your little omega sign. So this is just Ohm's Law real quick in this little formula, quick and concise. V equals IR. I always remember it this way. This is the only formula I ever remember, and then I will use this to rearrange it algebraically to get whatever I need. So all you really need to memorize is just V equals IR, and that's pretty much all of Ohm's Law. But I'll show you guys that in a minute. So just know that V is volts, amps is I, and R is resistance. And just to tell you guys what happens, R resists the flow of current. It is a resistance, something like a wire or a light bulb or a heating element or anything with a resistance is R. So it has a resistance, and that is measured in ohms. If you guys want a little bit more detail on that, watch my basic physics behind electricity parts for resistance, and it will talk about resistance. Same for voltage and current. I have videos on all these that explain what's going on in great detail. But so I is how much current is flowing at any given time, and V is a potential difference or a voltage. That's what you need to actually push some current through a resistance. So V pushes current through a resistance. So that's kind of what's going on here. So just so you guys understand that. So now let's look at what we can do with this algebraically. So we take that away. So now if we take that V equals IR and run with it, you can see that you can quickly rearrange this into any formula that you want. And you might have seen this V I R, this little triangle looking thing where they make it into like a triangle like that. And this is just to kind of help you. This is another way of memorizing it. I don't really use this way, but it's a good way to memorize it. So you can cover up whatever you're looking for, or whatever is missing, so whatever you're looking for. So if you're looking for voltage, if it's on the bottom, these two you multiply, so you do I times R, so that's V equals IR. If you're looking for resistance, you cover up the R. V divided by I is equal to your R. So whatever one you're missing, you just cover up, and it shows you kind of what operation to do. If I was looking for I or the current, I'd cover up I, and V divided by R is I. So it's a very easy way of doing it. So there's the triangle method. I personally just remember this formula. It's very easy to memorize, and I just manipulate it. So if I was looking for say I could just divide each side by R divided by R. These R's will cancel, and V over R equals I. And you can do that in any way. You could have said V equals I R, and if I was looking for say R, I could divide each side by I, cancel those out, and V over I is R. So that's one way of doing it. So that's how you can just memorize that one formula, and you can manipulate it to find whatever variable you're looking for, or you could use this triangle method if that's what you like. So now that we've done that, let's go into something else. So there's one other formula I want to give you guys, and that is P equals V times I. And P here is power in watts. So this is power. That's what P stands for. So now that we have this formula, we can take this and blend it with that V equals IR. So now we also have our V equals IR. And there's not really like a triangle or anything for this one. Sometimes you'll see this like wheel thing. It's like a chart, kind of like a little pie chart, and it has like a bunch of formulas in it. And you can memorize all those. I mean, that's one way of doing it, but I highly discourage from memorizing it because you can memorize it wrong, and it doesn't really teach you anything. You don't learn anything from it. It's very easy to just memorize P equals volts times amps, so power is equal to volts times amps, P equals VI, and V equals IR. And if you memorize those two formulas, you can substitute into either formula, and you can just solve for whatever you're looking for. So if I wanted to solve for power, and I knew, let's just say, volts and ohms, let's say. I didn't know the current. So you can mix these two formulas together. So we could solve this formula down here for I. So if we divide each side by R, right? R, I equals V over R. So now I know that I is equal to V over R, and I could take this I and plug it in up here. So P equals V times V over R, or equals V squared over R. So that's how you can just memorize these two formulas and kind of substitute them in and plug them in to make whatever you need to kind of come up with whatever missing variable you're looking for, whatever variable you're missing. Solve for that variable in either formula and plug it in. So that's pretty much Ohm's law altogether, just for DC circuits. Again, this definitely does not apply to AC circuits. This power formula only applies to DC circuits, because in AC circuits your current and voltage may not always be in phase with each other. And again, that's why I said Ohm's law doesn't really even apply to AC circuits. There's a very specific circumstance in which you can apply it to the AC circuits, but for the most part, you have to have a good reason to do it, and you shouldn't really do it unless you really know what you're doing. So Ohm's law, and especially this formula, does not apply to AC circuits for most cases. So this is all DC circuits, and that's pretty much it for Ohm's law. I mean, again, I didn't really show exactly what's going on here with the original formula. It's kind of important that you understand this, but like I said, volts pushes current through a resistance. That's really all you need to understand. But if you want to understand it in much more detail, go ahead and watch my the basic physics behind electricity videos, and I will explain all this stuff in great detail. But that's pretty much Ohm's law, just in a quick 5-minute video. Hope you guys enjoyed this one, and as always, have a good one.